Episode 56 AE. Checking machines for corrosion and the guy wires for proper tension. Checking for and replace any worn leading edge tape on the turbine blades, if appropriate. Replacing components such as turbine blades and/or bearings as needed. Your installer may provide a service and maintenance program or can recommend someone who can. Siting a small electric wind system. Your professional installer should help you finding the best location for your wind system. Some general considerations they will discuss with you include wind resource considerations. If you live in complex terrain, take care in selecting the installation site. If you site your wind turbine on the top of or on the windy side of a hill, for example, you will have more access to prevailing winds than in a gully or on the leeward, sheltered, side of a hill on the same property. You can have varied wind resources within the same property. In addition to measuring or finding out about the annual wind speeds, you need to know about the prevailing directions of the wind at your site. In addition to geological formations, you need to consider existing obstacles, such as trees, houses, and sheds. You also need to plan for future obstructions, such as new buildings or trees that have not reached their full height. Your turbine needs to be sited upwind of any buildings and trees, and it needs to be 30 feet above anything within 300 feet. System considerations. It is encouraged that you only consider small wind turbines that have been tested and certified to national performance and safety standards. When siting, be sure to leave enough room to raise and lower the tower for maintenance. If your tower is guyed, you must allow room for the guy wires. Whether the system is standalone or grid connected, you also will need to take the length of the wire run between the turbine and the load, house, batteries, water pumps, etc., into consideration. A substantial amount of electricity can be lost as a result of the wire resistance. The longer the wire run, the more electricity is lost. Using more or larger wire will also increase your installation cost. Your wire run losses are greater when you have direct current DC instead of alternating current AC. If you have a long wire run, it is advisable to invert DC to AC. Sizing small wind turbines. Small wind turbines used in residential applications typically range in size from 400 watts to 20 kilowatts, depending on the amount of electricity you want to generate. A typical home uses approximately 10,649 kilowatt-hours of electricity per year, about 877 kilowatt-hours per month. Depending on the average wind speed in the area, a wind turbine rated in the range of 5 to 15 kilowatts would be required to make a significant contribution to this demand. A 1.5 kilowatt wind turbine will meet the needs of a home requiring 300 kilowatt-hours per month in a location with a 14 mile per hour, 6.26 meters per second, annual average wind speed. A professional installer will help you determine what size turbine you'll need. First, establish an energy budget. Because energy efficiency is usually less expensive than energy production, reducing your home's electricity use will probably be more cost-effective and will reduce the size of the wind turbine you need. The height of a wind turbine's tower also affects how much electricity the turbine will generate. A professional installer should help you determine the tower height you will need. Estimating annual energy output. An estimate of the annual energy output from a wind turbine, in kilowatt-hours per year, is the best way to determine whether it and the tower will produce enough electricity to meet your needs. A professional installer can help you estimate the energy production you can expect. The manufacturer will use a calculation based on these factors. Particular wind turbine power curve. Average annual wind speed at your site. Height of the tower that you plan to use. Frequency distribution of the wind, that is, an estimate of the number of hours that the wind will blow at each speed during an average year. The installer should also adjust this calculation for the elevation of your site. Grid-connected small wind electric systems. Small wind energy systems can be connected to the electricity distribution system. These are called grid-connected systems. A grid-connected wind turbine can reduce your consumption of utility-supplied electricity for lighting, appliances, electric heating and cooling, and vehicle charging. If the turbine cannot deliver the amount of energy you need, the utility makes up the difference. When a wind system produces more electricity than your household requires, the excess is credited and used to offset future use of utility-supplied power. Modern grid-connected wind turbines will operate only when the utility grid is available. They can also operate during power outages when configured to work in tandem with storage to form a home microgrid to provide backup power. Grid-connected systems can be practical if the following conditions exist. You live in an area with average annual wind speed of at least 9 miles per hour, 4 meters per second. Utility-supplied electricity is expensive in your area, about 10 cents per kilowatt hour. The utility's requirements for connecting your system to its grid are not prohibitively expensive, and there is sufficient capacity to integrate your system. Your utility can provide you with a list of requirements for connecting your system to the grid. For more information, see Grid-Connected Home Energy Systems. Wind power in isolated grid systems. Wind power can be used in isolated off-grid systems or microgrid systems, not connected to an electric distribution grid. In these applications, small wind electric systems can be used in combination with other components, including a small solar electric system, to create hybrid power systems. Hybrid power systems can provide reliable off-grid power for homes, farms, or even entire communities, a co-housing project, for example, that are far from the nearest utility lines. An off-grid, hybrid electric system may be practical for you if the items below describe your situation. You live in an area with average annual wind speed of at least 9 miles per hour, 4.0 meters per second. A grid connection is not available or can only be made through an expensive extension. The cost of running a power line to a remote site to connect with the utility grid can be prohibitive. You would like to gain energy independence from the utility. You would like to generate clean power. For more information, see operating your system off the grid.